This is part 1 of the Chapter 8 review, and in Chapter 8 we're dealing with similarity. So let's go ahead and begin with problem 1. We're asked to find the scale factor. List all the pairs of congruent angles, and then write the ratios of the corresponding side lengths in a statement of proportionality. So we have 3 things that we need to do here for each problem. What we're going to do is we're going to use this similarity statement as our guide. This is going to be our map to determining which sides correspond to what sides in these 2 figures. For example, AB would correspond to EF, and BC to FG, and so on. In order to find the scale factor, we're going to use the destination divided by the source. Scale factor, remember, is a ratio of any corresponding linear measurement of 2 similar figures. In this case, 2 side lengths. So we're going to take a side length from this figure divided by a side length from this figure, because we're going from here to here, so it's destination divided by source. Now what we need to do is figure out which one of these sides to use. First we have BC. BC again corresponds to FG, but unfortunately FG doesn't have any values for it, so we can't use BC. Then we go to DC. DC is here. That corresponds to GH, and GH is here, so we can use that. For number 1, we write the ratio of GH to DC, which is 9 to 12, which simplifies to 3/4. Now, from a congruent standpoint, congruent angles, we know that angle A corresponds to angle E, angle B to F, C to G, and D to H. So those are going to be our corresponding congruent statements. We write angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. We just followed along this similarity statement. Now we want a proportionality statement. So the corresponding side lengths, AB corresponds to EF. So AB is to EF as BC is to FG as CD is to GH as AD is to EH. AD is to EH. And now let's do problem 2. In problem 2, we have 2 triangles, and in this case, our hypotenuse will be a good guide. We can use the hypotenuse because these are both right triangles, but we're also going to check it with our congruent statement just to make sure. So let's look at XY. XY is here, corresponds to RP here. It's destination divided by source, so we're going to have PR to XY, which is 10 to 25. This divides by 5 2 times, and this 5 times. So our scale factor is 2/5, going from here to here. Then we want our congruent statement, so we have angle X is congruent to angle R, Y to P, Z to Q. So angle X is congruent to angle R, angle Y is congruent to angle P, and angle Z is congruent to angle Q. And finally, our similarity statement will guide us to the ratios of our corresponding side lengths. XY to RP is the first one. XY is to RP as YZ is to PQ. YZ is to PQ as XZ is to RQ. XZ is to RQ. And it's best to use the similarity statement because your eyes can play tricks on you. If you try to use these sides, you may flip things around. This way, you're generally safe. Unless, of course, there's an error in the drawing, but then you can verify that because the similarity statement must be consistent with the picture. In this case, they were, so we're in good shape. Let's move on to the next problem. In this problem, we have two similar triangles have a scale factor of 3 to 5. The altitude of the larger triangle is 24 inches. We want to know what is the altitude of the smaller triangle. In problems like this, the best way to solve these, in my opinion, is to use a proportion. So we're going to start with the first ratio, 3 to 5. We have 3 to 5 equals, and this is the altitude of the larger triangle. 5 is the ratio small to big, so 5 corresponds to the 24. So we're going to put x over 24 to set up our proportion. Now that's all we have to do is solve for x. And we just multiply by 24. So 24 times 3 divided by 5. That gives us 14.4. So not too bad of a problem. Pretty straightforward. Let's move on to the next problem. This problem tells us that two similar triangles have a pair of corresponding sides of length 12 meters and 8 meters. The larger triangle has a perimeter of 48 meters and an area of 180 square meters. We want to find the perimeter and area of the smaller triangle. Now, let's go ahead and start with perimeter. And what we have is perimeter is a linear measure, and side lengths are also a linear measure. So we're going to have two ratios that are linear measures. So this means we're going to have a straight proportion. So let's put 8, the small, over the big. Those are our side lengths. And our 48 is the larger one. So that's going to correspond to the 12. And we don't know what the perimeter is of the small one. So we're going to put an X up there. Since these are linear to linear, there's no conversion that has to be done. So it's just a straight proportion. And what we're going to have is 8 times 48 over 12, which equals 32 meters. Now let's look at area. In this case, we still have a side length that we're going to start with. So we have length measures, and that's going to be 8 to 12 again. But then we have area. And the area of the larger one is going to be 180 square meters. And this, again, is going to be our variable, our x for our area. Now, since we're dealing with linear to area ratios, you have to use the basic conversion. The ratio of the areas is always the square of the ratio of the linear measures. So before we could put the equal sign in here, we had to square the ratio of those linear measures. Now, working this out, this is 64 over 144 equals x over 180. We multiply by 180. 180 times 64 over 144, and we put that in our calculator and get 80 square meters. So always remember, when you're dealing with a conversion from linear to area, the ratio of the areas is always equal to the square of the ratio of the linear measures. All right, let's move on to the next problem. In problem 5, it says show that the triangles are congruent. Write a similarity statement. Well, we see that angle Q and angle T have a measure of 35 degrees. So those angles are congruent. Let's get that out of the way and write that down. So for 5, angle Q is congruent to angle T. Now we don't have to write a formal proof. We're just writing down the things we know to show that these two triangles are similar. We know that RSQ and TSU are vertical angles, so those are congruent. So angle RSQ is congruent to angle TSU. And now, because this angle is congruent to this and this to this, these triangles are congruent by angle-angle similarity. And to write a similarity statement, what I'm going to do is start out with the known angles. So I'm going to say angle Q, so triangle Q, and then I'm going to go to the other known angle, which is S, and then the last one, R, is similar to triangle. We're going to start with that known angle, T, S, and then the last U. So that's number 5. Now let's go to number 6. Here we have two right triangles, one right angle. That makes these two angles complementary to each other. Since this angle is 60, this angle has to be 30. And here we have a 30-degree angle, so this one must be 60. So these triangles must be similar by angle-angle similarity. So 6. We know that angle C is congruent to angle F because they're right angles. We can use either E or A, doesn't matter. Let's use angle E. Angle E is congruent to angle B, and the triangles are similar by angle-angle similarity. For the similarity statement, I'll start with the right angle. So triangle C, and we'll go this direction to the 30-degree angle. B, A is similar to triangle, start at the right angle. F, go to the 30-degree angle. E, and then D. And there you have it. Let's do another problem.